Hey YouTubers, I'm Evan.
I'm Luis.
I'm River.
And this is our video report of Experiment 3, Determination of a Chemical Formula in Dr. Mullen's lab.
The objective was to synthesize and determine the empirical formula of the product of the reaction of zinc metal with solid iodine. To determine the formula of an unknown hydride. Elements combined in fixed radius to form compounds. For example, consider the compound aluminum chloride. Each molecule of aluminum chloride is composed of exactly one aluminum atom and 3 chlorine atoms.
A mole is a unit in chemistry that represents an amount of molecules, ions, or atoms. By definition, a mole is the number of atoms and 12 grams of C12. The number of atoms in 12 grams of C12 is approximately 6.022 times 10 to the 23, also called Avogadro's number. The mass of an element is equal to the number of moles of that element.
Suppose you don't know the formula of a particular compound. If you know the molar ratio, or two elements in the compound, you can use that ratio to determine the simplest possible formula for that compound.
The materials for this experiment are beaker of 100 milliliters, hot plate, unknown hydride, zinc metal, iodine, 0.2 molar acetic acid, crucible and cover, Bunsen burner, iron ring and ring stem, and wire gauze.
And then for part A of this experiment, the procedure, we started off recording the mass of a 100 milliliter beaker, which we got about 51.49 grams. And then we were instructed to add about 0.6 grams of metallic zinc into beaker. So we got about 52.17 grams of the zinc added with it. So all in all, after we subtracted, we got about 0.68 grams of zinc.
In step 2 of part A, it told us to put a piece of 0.6 grams of solid solid iodide on a piece of pre-weighted paper, and the pre-weighted paper came out to be 0.954 grams, and the paper with iodine came out to be 1.54 grams, which means the iodine that we put on the piece of paper was 0.636 grams, and it told us to record the mass of iodine added to the beaker, and we also added 5 milliliters of 0.2 molar acetic acid.
Okay, for step 3, we were told to mix the beaker occasionally and recording observations. About 20 minutes the reaction would take place. For what we recorded, we noticed that there was a color change when we first started, so that already tells us that that's a chemical reaction. And then as time got on, it started getting more dark, and the longer the 20 minutes went over, it just slowly started to go completely colorless. So at the end, we determined that the solution was colorless and there was a chemical reaction.
Once the reaction was complete, we contained aqueous zinc, iodide, and acetic acid. We carefully decant the solution into a clean 100 milliliters beaker, making sure that our zinc remained on the beaker. To that, we add about 3 milliliters of 0.2 mol of acetic acid to the beaker with the solid zinc. Swirling a few times, then decanting again. This was called washing the zinc.
The next step is to wash the zinc with water 3 times and put the water in the collection beaker. The next step is to put the beaker with zinc on a hot plate and heat it until it's dry. The weight of the beaker, once we heated it, was 52 grams. We heated it again for 5 minutes, and the results for that were 51.98 grams. If the results for the first time you heated it and the second time you heated it are close to 0.01 grams away, then you are done. And that is the end of part A.
Moving on to part B of the experiment with the unknown hydrate, we were instructed to weigh a crucible with cover, which when I weighed it, it was 45.73 grams, and then add about 4 grams of the unknown hydrate to the crucible and then record its mass again. So the crucible with the unknown hydrate was 47.0 grams, so about 1.27 grams of the unknown hydrate.
For the second part, we put the crucible into the burner and heat it for 20 minutes. After that, we cooled it to room temperature, and the first mass was 46.60 grams, and we heat it again, and the second mass was 46.59 grams.
The unknown mass of the hydrate, the first time we heated it, was 0.87 grams, and once we heated it the second time, it was 0.86 grams. Then, after that, we put a small portion of 6 molar HCl into a small beaker, and we lit the Bunsen burner. We took the spatula and cleaned it with the HCl, then put it on the flame. And then no color change happened, so we knew that the spatula was clean. We put some of the remaining unknown onto the metal spatula and placed it in the flame. If you see a red flame, you have strontium chloride. But for us, we put it on the flame and nothing happened. So that rules out it being strontium chloride.
So after we determined that it wasn't that, we were instructed to put a small portion of the unknown hydrate in a test tube, add a few milliliters of water with a strip of magnesium metal, and wait about 5 minutes. And we were instructed that if you see a dark substance, you have zinc sulfate. If you don't, then you have magnesium sulfate.
After waiting for 5 minutes, we got a dark substance, so we knew that it was zinc sulfate. So the mass of the lost water was 0.4 grams. We wanted to know how many moles of water we lost, and we divided 0.4 grams divided by 18.01, and the result was 0.02 mole.
For the conclusion, we didn't really make any errors. To possibly get an exact or a better number than what we had, we could have heated our solution a little bit longer to get a more exact number of what the metal weighed in the solution. We noticed around our lab that other students, when they were doing this, they had some spilt solutions, spilt metal, didn't get the exact weight of what their metal weighed. At the end, if you can write down what exact number you had for that, that'll give you a more exact and more accurate answer for your final outcome.